Right, so this is my setup. This is all the equipment that I brought from school for this experiment. We have a power source plugged in that I can use for AC or DC. Today I'm going to use DC only. And I have my own phone set up to record a time lapse of what we're going to see underneath here. And I want a time lapse because it's going to happen very slowly, and then when I finish the time lapse video, we're going to see the the semolina seeds actually moving, taking shape of the electric field. So what are semolina seeds? What do I have here? Semolina is actually little small particles that is actually sometimes used in cooking. I can make some dessert with this. I know a lot of people do. So the special thing about semolina seeds is, well, they can float on castor oil that I'm going to use to fill in my petri dish here today, and they can be polarized. So they can be polarized means they can be affected by the shape of the electric field, just like iron filings would align themselves with the shape of a magnetic field, which we will also see at the end of the unit. So we're going to put some castor oil on the petri dish first, and I'm going to sprinkle semolina seeds on the surface. The castor oil makes the semolina seeds float. It's an insulator, and it is there to give us the medium for the semolina seeds and the electric field to form, and the seeds will take the shape of the electric field. So castor oil is to provide the medium for us. These are going to be the particles taking the shape of the field lines to show us the field lines. And I'm obviously generating electric field from my source. I'm going to plug one end to here and the other end to here, and when I do that, I will end up that end and that end being a positive terminal and the negative terminal, and eventually this is going to cause an electric field between these two poles in that region, and the floating semolina seeds on the castor oil are going to show us what kind of electric field lines we get. I'm going to take that off, and I'm going to put these in, which is going to show us, so once I squeeze it in, I'm going to be able to see a parallel plate. So now the charges that come from the source to here will actually be able to collect on this line. So when I put that on one side and this on the other side, that will now show us parallel plates. And in class we learned that if we have two parallel plates, the alignment will have to be straight lines between and curved on the edges. All right, so this is what we see, what I got with two pole terminals. On a close-up, this is what pattern I got. I wasn't very convinced with this, so I'm gonna insert one from previous year's recording. So here goes one from before. You can see that the field lines follow the pattern that we expect in that sense, and then here is the parallel plate version.